Right, okay. For the one who has asked question, Sachin, is that you? Did you ask the question or Sitmi? Who asked the question?
Yes, sir.
Sitmi, right, okay. Sitmi, so is it clear now? If you take project table, project ID is the clear primary key, and that is the clear candidate key, and that will become the primary key. Here, employee table, employee ID is the clear candidate key, and that will become primary key. Right? And right. In project, if it is project table, project ID, if it is employee table, but this is project member. This is to allocate members to the projects and the hours work at the particular project. So now you can see, for an example, let's say Sirisena can work for road construction project, and he can work for some maybe power plant project. And again, Rajapaksha can work for power plant project, maybe some whatever construction project or Lotus Tower construction project or some like. So one can work for many projects, right? In the other hand, one project may have many employees, many members. So it is many to many relationship. When you have many to many relationships, you break down, you create another table that is basically project member table. Otherwise, it will be difficult to fill data. Now, so here one member can work for many projects. That means, for an example, project ID 1. So both Rajapaksha is working, and same project, Sirisean is also working. 202 is also working. Right? So project 2, project number 2, only Rajapaksha is working. So likewise, you can add. So the combined primary key, this is called composite primary key. Sorry, compound primary key. So not composite. Composite means if you select two keys from the same table, it's composite. But this is compound. Compound means you take primary keys from two tables as foreign keys and create your own primary key in the next table. Did you understand the concept? Sidney?
Yes, sir.
Okay, I think now it's clear that why we are not using only project ID. So there are tables, there are some more tables, right? So here they have just mentioned only about one particular, one specific table only. That's why this is, it seems like unclear. But if it is given like this with other two tables, so then that will be clear, right? I have given the other two tables to explain the scenario. I think now it's okay. Right. Okay. So let's move to the next one. Okay. Let's move to the next one. Now, using letters instead of column names, right here actually to explain the functional dependencies. So the same thing. So you have used letters, right? But we have used column names, right? So here actually they have used letters, but I have used column names. So that is both are okay. Right. Then normalization criteria. Actually, we should know what is the criteria which is used for normalization. The first one is, okay, this is very, very, very important, right? So you have to put like triple asterisk and write down this in your book, because so when you, so there will be question in your paper asking this table in which normalization form? Is it in 1NF, 2NF, 3NF, or BCNF? BCNF actually it's not in your syllabus directly, but 1, 2, 3NF are there. So if you have atomic values, definitely the table in 1NF. What is atomic value? See here. Last week also I said, if a single cell has multiple values here, own ID, he owns 3 cars. So single cell has multiple. Here on ID 3 owns 2 cars. So then this is not in first NF, 1NF, because it consider only atomic value. Only one value can be there in a cell. So this is not in 1NF. So how to make it 1NF? How to create this 1NF? So one format is this. So on ID, car1, car2, car3. You have 3 cells and you can store, but there you can see some null values might appear. Some null values might appear. So having null values is not really good. So this another one, another solution is you can say, so you can normalize this in this way. You can put the car registration number and you can put the own ID there. Now you can see creating this new table. So this registration table mentioning the owner ID. Now this is not having null values, but this one will have null value. This is also a solution, but this is also a 1NF solution, but this has null values. So avoid that. Let's go for this one. This doesn't have null values. And again, same data is represented. This is what expected in 1NF. Okay, shall we write down this, the summary? Normalization criteria, please write down. No need to draw this, just write 1NF, atomic values for each attribute. 2NF, no partial functional dependencies. 3NF, no transitive functional dependencies. BCNF, no other functional dependencies. Please write down 4 normalized forms and the special criteria in front of that. Please do that. Don't draw this, no need to draw. Just write 1NF, put a dash and write only atomic values. 2NF, put a dash, no partial functional dependencies. 3NF, no transitive functional dependencies. 4NF, or it's not 4NF actually, BCNF, boys called normal form, no other functional dependencies. Please write down. Right, okay. So now you saw the atomic value thing. So what is atomic value? Basically, so this is called multi-value. So multi-value attributes. So this is called multi-value attribute. Multi-value attribute. So this is called multi-value attribute. Target is to remove this multi-value attribute. Solution 1. So I think you better draw this, right? Solution 1 is this, but this has some issues. So this has some issues. Actually, these are the issues. When you're going to break down this into this kind of table, so you will get null values. These empty points are called, these empty things are called null values. So having null values is not good for, it is not really good. Having null values is a problem. Therefore, it's not a good solution. So no need to write down note, right? So please show this. These are repeating groups, or we call multi-value attribute, or repeating groups. So then you can break down and create another table. So that is this one, but it has null values, which is not a very good solution. So show this first. So write in 1 or 2 enough, 2 rows enough. No need to write all 3 rows. Write in 2 will be enough. You can use the car registration because this is unique. You can see the car number is unique. So it depends on the data, right? So we cannot say tell that it is always you have to do the same. Depends on the data. So if it is something like this, so let's assume here you have right owner ID or owner name. They are in the second column. You have telephone number. So in that case, you can say telephone number is unique. Owner ID is 1 and 3 telephone numbers. Owner ID is 2, 1 telephone number. Owner ID is 3, like 2 telephone numbers. Now you can find telephone number is unique. So when you find telephone number is unique, what you can do, you can write the telephone number in the beginning and then the owner. Right? So owner will be repeating something like the vehicle registration number in the beginning and owner is in the second. So this is so something good because this doesn't have null values. No need to write the note, right? Don't write the note. So this is the second solution. If you tried that, you could have come up with this. I already actually displayed this, but you can also try. So take a snap or write as solution 2. So this is the solution 2. So previous one is solution 1, but it is not good since it has null values, but it is still valid solution, right? It's not good, but still valid solution. So solution 2 is this, where you can have the primary key as the registration number and owner ID is the foreign key. Owners in another table, owner ID and owner name may be in that table, registration number and owner ID another table. Okay, I'll give you simple exercise. So please write down this. I'll give you simple exercise and try to normalize this to 1NF. Okay, I think you have done this. If not, take a snap and write down separately. Okay, let's try for an example. Okay, I'll give you a table. Check whether this is in 1NF. I have a table like this. Teacher name, sorry, I have teacher table. There I have teacher ID, teacher name, and tell. So this is how the values are organized in the teacher table. This is how the values are organized. TID, TName, and tell. So first teacher is, let's say, teacher ID. I need teacher ID actually, sorry. 1 Kanishka Di Silva and 071 and teacher has another telephone number. Right, teacher ID 2 and telephone numbers. Teacher ID 3 okay, this is teacher table. Is it in 1NF? Is it in 1NF? You have to give me the answer. Is it in 1NF? So let's do together, right? Otherwise it will take some more time. Let's do together. Is it in 1NF? Is it in first normalized form? Yes?
No, sir.
No. Why?
Telephone number multi-valued
Yeah,
attribute.
it's multi-valued attribute as well as you can say repeating groups. So repeating groups should be removed. So I'm going to create another table. So my solution to this will be, I'm going to create another table that is teacher table. In teacher table, I'm going to store this two only two things. So I'll store this in the teacher table. Right, this column is not required. Let's delete. Okay. So this is my solution. One is this, but you can't miss the teacher telephone number. Therefore, I'll create another table that is teacher tell. Teacher tell, and I'll create another table. There I'll mention two column again. First one is tell and second one is teacher. Or belongs to, or maybe teacher or teacher TCH or teacher ID, even anything. You can give like anything, right? So then you can mention the telephone number. So this telephone number is belongs to teacher ID 1, and this telephone number is belongs to the teacher ID 1 again. So this telephone number is belongs to teacher ID 2, and this telephone number is belongs to teacher ID 3, and this one is also belongs to teacher ID 3. So then teacher ID will become a foreign key. How you link these two tables? By having the primary key and foreign key relationship. This is the primary key. I'm going to put this as the foreign key for this table. So this is the solution for the problem which is given. So shall we take screenshot? So because when you are going to write, this will take more time, right? So I think you can understand what is first normalization for 1NF. I think you can understand what is 1NF now. Okay, let's learn about 2NF. So let's discuss about 2NF. In second normalization form, so what you are going to look at? So here, according to your note, so it says no partial functional dependencies. Second normalization form focusing on, okay, 2NF. Please write the heading 2NF or second normalization form. The condition 1. Table must be in 1NF. Otherwise, nothing called 2NF. So if table is not in 1NF, you don't talk about 2NF. Table must be in 1NF. Table එක අනිවාර්යෙන් 1NF තියෙන්න ඕන. එහෙම නැත්නම් 2NF කතා කරන්න එපා. 2NF කතා කරන්න බෑ ඇත්තටම. Okay, the second thing is, this is condition 1, and the second thing is no partial dependencies. So what is partial dependency? What is partial dependency? What is partial dependency? Partial dependency is something when you have like a composite primary key. So this happens when you have a composite primary key. For an example, you have a table like this, right? In this table, you have like, okay, let's say you have composite primary key. Composite primary key means, let's say, teacher ID, department ID. You have teacher ID, department ID, then teacher name, then department name, and maybe join date. I'm taking these examples then and there, right? But it doesn't matter. So I'm going to explain this using the same scenario. Let's say teacher ID 1. Teacher ID 1, department ID 1. Teacher ID 1, you know, Kanishka De Silva. Kanishka De Silva is teacher 1. And department name, let's say mathematics or science. And join date, let's say, or joined January 2020. So department teacher ID 1 plus teacher ID 2 serving for department ID 1 again. So teacher ID 2 is Malshan Ranavira is working for department ID 1 which is science department since December 2019. And there's another teacher, so that is same teacher, let's say same teacher Malshan Ranavira is working for another department that is statistics or engineering. So let's say he's working for another department, so same teacher, but it's working for engineering too. And since, let's say he's working for engineering department since January 2018. Okay, let's say you have a table like this. Now, is it in 1NF? Is this table in 1NF? Is this table in 1NF? Or 2NF? Sorry. Is it in 1NF? Let me know first. First normalized form එකේද තියෙන්නේ නැද්ද? You need to give the answers, guys. Is it in 1NF or not? Yes? Yes, it is in 1NF. Surely it's in 1NF. Why no multi-value attributes? Multi-value attributes ne? ඔක්කොම atomic values. So it is in 1NF. This table is in 1NF. Okay, you can say yes, this table is in 1NF. This table is in 1NF. No doubt about that. But the problem here is, what is the primary key of this table? Primary key of this table. Can anyone tell what is the primary key of this table? Yes? Is teacher ID primary key? Is department ID primary key? Is teacher name primary key? Is department name or joined it anything? What is the primary key? Can you suggest? Come on, guys. You have to.
TID and department ID.
Yes, TID and department ID together will become the primary key because no primary key is there. So you have to combine two things, and now you have composite primary key. TID and depth ID. This is called composite primary key. Since you don't have single primary key, you assign a composite primary key. Partial dependence is happening when you have composite primary key. That means if some other key is dependent on part of the primary key, then that is called partial dependency. Okay, what is partial dependency? Please repeat it. If some key is dependent on part of the primary key, right? When you have a composite primary key, if any key in the table depends on part of the primary key, then it is called partial dependency. Okay, this is the explanation for partial dependence. When you have composite primary key, it is compulsory to have a composite primary key, otherwise there's nothing called partial dependency, right? Composite primary key එකක් තියෙද්දි විතරයි partial dependency එන්නේ. තනි primary key එකක් තියෙද්දි partial dependency එන්නේ නැහැ. Any key in the table depends on part of the primary key. That is another point. So if so, that is called partial dependency. Now you can see, so these are the partial dependencies available in your table. One partial dependency is that you can identify here department name is depend on department ID. Here, department name is depends on department name is depend on department ID. That is a problem. This is not a good drawing. Let's use let's use this, right? Department, you can say department name depend on department ID. That is not good. And another thing, there are two partial dependencies. The second partial dependency is that you can see, sorry, the second partial dependency is that teacher name depends on teacher ID. So you have two partial dependencies, therefore this is not right. You can see there are two partial dependencies. So table is not in 2NF. There are two partial dependencies. So table is not in 2NF. So please write down this. This is very important. So because I think the short note won't explain this one. So please write your own note on this. So that is the note given by me. You can write this one also. So what is known as partial dependence? If part of a primary key is depend on, if part of the primary key is depend on, sorry, if any key is depend on part of the primary key, then that is called partial dependence. And let me highlight the primary keys in some another color, right? Just to identify, let me make it blue color. These are the primary keys. You can see department name depend on department ID. That cannot happen. Teacher name depend on teacher ID. That cannot happen. Right? So please write what is partial dependency and how it happens. Please draw this, write and draw this.